Our next series of sequences is called geometric sequences. Well, within geometric sequences, what's different than arithmetic is arithmetic had a common difference, which was an addition or a subtraction of a value. Well, here with geometric, it is actually a multiplication of a common ratio. So, for example, if you look here, how did I get from 7 to 14? Well, normally you would say plus 7. Does that continue here from 14 to 28? No. So then, one easy way to do that, to determine if the common ratio exists, is to take the bottom number and divide it by the previous number. So 14 divided by 7 is 2. Is that consistent here? 28 divided by 14 is also 2. So we found our common ratio. Sometimes the common ratio is actually a multiplication of a fraction. So here's an example. If this is 18, the next one is 6, and the next one is 2, here you would say, all right, that's going down by 12, that's not going down by 12. Take 6 divided by 18, that is 1/3. That's also consistent here. The common ratio is 1/3. Well, the explicit formula for geometric sequences is as follows. A sub n is equal to a sub 1 times r to the n minus 1 as an exponent. Well, that formula is really close to what we talked about with exponential functions. If you notice, there's definitely some similarities here. Where for us, earlier, this was the y-intercept. Here, this is just the first value. So let's kind of change this formula using f of n. So we could say f of n is equal to f of 1 times r to the n minus 1. Same exact formula. So let's take a look at this pattern. How am I getting from 2 to 10, from 10 to 50, from 50 to 250? Is by multiplying by 5. So my pattern exists, and my formula will be f of n equals the first value. Well, the first answer is 2. The common ratio is 5 to the n minus 1. So if you wanted to find the 10th value, simply substitute in 10 for the n. 10 minus 1 would be to the 9th, and then you'd work that out. All right, the recursive formula is basically just taking the previous answer and multiplying it by r. So let's just use this example here. If I knew a sub 1, you basically need the initial value. A sub 1 is 2. Then if I want to know a sub 2, I need the answer to a sub 2 minus 1 times by that common ratio of 5. Well, the answer from the a sub 2 minus 1, which is a sub 1, we can check right here. A sub 1 was 2. So 2 times 5, a sub 2 is 10. And then if we continue that pattern again, a sub 3 is equal to the a sub 3 minus 1 multiplied by that common ratio, which is consistent all the way through. A sub 3 equals the answer from the second position is actually right here. And basically what you're doing is just continuing the pattern all the way through. And you get 50. And you continue that, and that's a geometric sequence.